For this first Unit 1 review video, I am going to do number 5 from the end of Chapter 3. This program asks you to compile a list of all of the prime numbers between 1 and 100. Now this is number 5 in the new textbook, the purple 9th edition, and it is number 14 in the old edition, the 8th edition Savage Text, which is the green textbook. This problem gives you a hint and says one way to solve this is to use nested loops. So that's what we're going to do. We're going to use some nested loops, and then also we will use our Boolean data type as a flag and the modulus. So I'm going to create a new project, and I'll call it Unit 1 Review, and then 3 dash, be dash 5 for the new text, dash 14 for the old text. Prime numbers. Okay, I'll create a folder for it. Let's call it prime numbers. Okay, and I'll say this program will compile a list of all prime numbers under 100. Okay, so what we're going to do in using these nested loops, we need one loop to go through or iterate through every number from 3 to 100, and of course we know 0, 1, and 2 aren't considered prime. So we're starting at 3 and going to 100. That's the outer loop. Then the inner loop has to go through every number from 0 up to the number that the outer loop is on and test it by dividing it to see if it divides it evenly. Okay, so my outer loop iterates through 3 through 100, and I'm going to use a for loop since we know, and if you know how many times you want your loop to execute or iterate, then use a for loop. So a for loop, we declare the integer n, set it equal to, I'm going to start at 3 here, semicolon, then n less than, we'll go less than or equal to 100, I guess, and then n increment by 1. Okay, so our outer loop is going through all those numbers, and then our inner loop sees if any number from 2 up to that number, and that number is going to be n. We're going to actually use the number that's the counter or the iterator here in the outer loop. That's going to be the number we're testing. So we're going to see if any number under that n can divide that number in evenly. Okay, so for this inner loop, I'll pick a different variable name. I'm going to choose D for the denominator since we're doing division here. And that one we're going to start at 2. And we're going to go until that we'll try every single number that's less than our number n. Okay. All right, so that gives us our two numbers. These are the number we're testing to see if it's prime, and then D will be the number we're trying to divide into it. So we're trying to prove that a number is not prime, or prove that it's prime by not finding any counter examples to prove that it's not. So it's proof by counter example. What do we do when we find out, or first of all, how do we know that it divides it evenly? That's going to be the modulus. So if I'm going to do n modulus d equal to 0. If n modulus d is equal to 0, then we know the number is not prime. Okay, so but then this program's supposed to be displaying all the prime numbers. So how do we go about, displaying or not displaying a number? How do we control that? Well, the way I'm going to do it is I'm going to create a Boolean variable that I'm going to be using as a flag. So I'm going to call it bool is prime. And what I'm going to do inside the inside the outer loop, but above the inner loop, I'm going to initialize it to true. So we're going to assume that the number is prime until we find an example that proves it's not. And that's what's going to go inside this if down here. Is prime, I'm going to set it equal to false if we find an example D that will divide it evenly. The modulus being, if you've forgotten, the modulus is the remainder after division. So if the remainder is 0, then we know it divides it evenly. Okay. So the outer loop, we start with a number. It'll start with 3. We're going to assume it's prime. The inner loop will go from D all the way up to that number n. If in the first iteration it'll be 3, so that's not going to go very far. And check to see if any number divides it evenly. If it does, then we're going to set that flag to false. And then after that inner loop is done iterating, then that's where I'm going to display my number if it is prime. So I'm going to do if, and if you've got a Boolean variable, you don't have to say if that variable is equal to true or false. It's already carrying that true or false value in it. So I'm just doing if is prime. And so if that if is prime is still true, so we didn't find a counterexample, then we are going to output that number n. And I'll put an n line in there as well. Let's go ahead and run this and see how we do. And it should just spit out a list of all the prime numbers under 100. Provided, oh, of course I forgot my using namespace standard. And that's what this means. If cout was not declared, if it thinks cout is a variable, then you know you didn't include that namespace, so it knows that what the definition of cout is. Okay, here's the result. 3, 5, 7, 11, 13, 17, 19. That looks to be correct. Okay, now the textbook also says you can make this program more efficient a number of ways. Now, as far as efficiency is concerned, when I hit run, it's not taking very long, other than the compiling portion, which does sometimes take a little bit of time. Other than that, once the program executes and the console window appears, it's just spitting those values out. But if you are writing applications that are dealing with for businesses that are dealing with large data sets, then you're definitely going to want to make sure that your program is as optimal as possible so that the program doesn't get bogged down in its processing. So what things can we do to make this more efficient? Well, the first thing that might come to your mind is, well, if I find an example, all I need is one example to prove that it's false. And once we've done that, this loop will actually go back and keep looking for other examples, or it's going to go all the way up to d less than n. So if we found one example, we don't need to continue this loop anymore. Something that you should have picked up from the reading and the PowerPoint notes is the word break. Not only does it break out of cases in switch statements, it will also break out of a loop. So here, if I put this break statement in there, we're going to be that'll exit the inner loop once we found a single example. There's no point in continuing to look for other numbers that divided evenly. Okay, so that's one thing we can do to make it more efficient. And you're not going to notice a difference, really. We're talking milliseconds difference here. Later on in the semester, we're going to be doing a program with using linked lists and recursion. The recursion problem that we do, we'll actually look at some marked difference between performance using two different techniques. But for this, just iterating through 100 numbers, you're not going to notice much of a difference. Okay, that's one way to make it more efficient. Another way to make it more efficient, if you math whizzes out there may have already thought that if I need to find any number that is a factor of n, I don't need to search every single number less than n to find if there is any factor. I don't have to go look through all of them. I really only have to look through half of them because think about it. If you have a number, let's say I had a number 25. So I don't know if you recall writing out your factors. If I need to find, actually 25 is a bad example. Let's pick something else. Let's do 48. If I'm trying to find a number that divides 48 evenly, well, obviously 2 divides it evenly. You get 2, and then its counterpoint is going to be 24, right? For every number that you find that divides a number evenly, they're factor pairs. So one factor pair is going to be in the lower region, and then the other factor pair is going to be in the higher region. And then 4 and 12 is another example. So if we wanted to be even more efficient, we could just go to the square root of n, of that number n. So less than or equal to the square root. And of course, to use the square root function, you would have to include your C math library. Okay, let's try that. Okay, that works as well. Now this, putting the square root right there will actually calculate the square root every single time this thing iterates. If you wanted to be even more efficient, you would create a variable double, maybe square root, and do the calculation just one time. here, and then have this just look at the variable storage location square root. Okay, so there's the results, and all the results have been the same every single time. We've just been experimenting with different ways to run this inner loop to make our program more efficient. So that concludes this guided practice. Be aware of this nested loop type structure. Be familiar with it. Understand this. Hint, hint. You may need to hint, hint. Use this on the exam. So, happy programming. Don't forget to email me with your code if you're having any problems. C++ is an especially difficult language, and if it's your first language, even more so. Like I said, don't be afraid to email me with any of the issues you might be having. Thanks for watching, and make sure you know yourself.